All right, guys, let's go ahead and get started. Is it morning? Yeah. Good morning-ish, kind of. 11's kind of in that gray area. Is it afternoon? Is it? Anywho, today's lesson is based upon a lesson we had a while ago, or a concept we had a while ago. We talked about something that was ratios between two similar objects. We call them scale factor. When we had two similar objects, we get a scale factor between those two objects, and then we could find sides that would match up with other sides, so we could actually solve for stuff. Well, we're going to expand that to areas and volumes. Can we close our computer? Without breaking stuff? All right, so the first thing we're going to start off is something called length ratio, which is the same thing as scale factor. So when I want the length compared to that length, I'm really just doing the scale factor we've done all of the time. So this is the exact same thing as a scale factor. Today we might call it a length ratio, but it's the same thing as a scale factor. It is the ratio between two lengths or two segments of similar objects. So we have up here, yours should have a similar between it. Mine turned into a colon for whatever reason, but we should have triangle ABC is similar to triangle XYZ. So let's talk about ABC and XYZ. I want to compare one length to another length of XYZ, but they must be corresponding lengths. What could that fraction be if I'm just comparing two corresponding parts between ABC and XYZ? What are two corresponding parts of both of those triangles? Hamza?
12 and 15, and then 16 and 20.
Either one of those pairs would work. Yep. Because 12 compares to 15, and 16 corresponds to 20. We just got to be careful what order they want it in. They say compare triangle ABC to XYZ. So if I'm doing 15 and 12, I have to do 15 over 12. So we're going to do 15 over 12. Now if I simplify that, that's going to become 3 over 4. Note, that's going to be the exact same thing. Ooh, hang on. That'd be 5 over 4. Let's just slow down. That's going to be the exact same thing as if I use that 20 over 16. As long as they're corresponding parts when we put in the fraction and they are similar, you're going to come up with the exact same scale factor. Now we're going to see how that plays out with our areas. So it tells me to put the area of ABC over the area of triangle XYZ. Just remember, area is 1/2 base times height, so the area of ABC is 1/2 of 20 times that 15 all over on the area of XYZ, which is 1/2 its base, which is 16, times 12. Well, half of 20 is 10. 10 times 15 is 150. Half of 16 is 8. 8 times 12 is going to be 80 plus 16, which is 96. Now I want to simplify that fraction as far as I can simplify it. Can someone help me simplifying this? What does that simplify to? Yeah. We can go a little bit, not 33. You were close, yeah. 25 or 60. Did you say 32 or 33? Okay, yep. Then we can go one step further and make that into 25 over 16. Now look back at your scale factor. Look at your scale factor and your area ratio. What's similar about those? What's similar about your scale factor and your area ratio? Yeah. Not double, but squared. Yep, it's going to be squared. Where, Grant, guys, that's going to equal 5 squared over 4 squared. So your scale factor squared is going to be now your area ratio. We're not really talking about volume today. We'll talk about that at a later event. But what do you think the volume ratio is going to be? If our area ratio is its squared, what do you think the volume ratio is going to be? Yeah, cubed. It's not important you know that today, but it's going to be a good side conversation when we get to our volume. So that means for any similar shape, if the length ratio is A over B, your area ratio is going to be A squared over B squared, and your volume ratio is going to be A cubed over B cubed. I'm going to stay on this slide for just real quick. Length ratio. Length ratio, previously to this lesson, we called that a scale factor. So anytime I ask for a scale factor, I'm just asking for a length ratio. What's the ratio between two given lengths? The also important thing I'm going to talk about this is our scale factor is A over B. That is also going to be your perimeter ratio. That's going to be important to know that those two things are the exact same item. In fact, the very first questions on the homework are your scale factor and your perimeter ratio. Yeah.
So length ratio, perimeter ratio, and scale factor are all the same.
All the same thing. Because think about what your perimeter is. It is just adding those elements together. It is still the same ratio as one length.
But isn't the perimeter ratio adding up all the sides of it?
Mm-hmm. But when you reduce it, it'll be the exact same thing as your scale factor.
Oh, okay.
So if I would have known all of these sides, say if I knew all of these and these and these, if I would add up all of these and divided it by all of these, we'd come up with 5 over 4. We did that in a lesson previously. We added them all up and just showed that it stays away. So your scale factor is the same thing as your perimeter ratio. All right, our first problem says that we have ham and rib, and they're both triangles. And it says AM equals 16 centimeters. Then it goes on to say that the area of ham is 96, and it says the area of rib is 54. The first thing it asks you to do is come up with the area ratio. So our area ratio is just area of ham, which is 96, over your area of your rib, which is 54. What does 96 over 54 simplify to? Yeah? Man? 16 over 9. So our area ratio is 16 over 9. Now I want us to note what B is asking for. B is asking for a length. Do you think I'm going to use the area ratio to find a length? Is area ratio the same thing as length? Is area the same thing as length? No. So instead of having an area ratio, I'm going to need to come up with our length ratio, which is also called our scale factor. If my area ratio is 16 over 9, can someone tell me what my length ratio is then? Yes. It'd be 4 over 3. Perfect. It would be 4 over 3. Because our area ratio is 16 over 9, we could think of that as being 4 squared over 3 squared. Or we could just think, well, I have to take the square root of 16 and 9. This is the square root of 16. This is the square root of 9. Kind of our tip-off is, this is 96 centimeters squared. To get rid of a square, I have to take the square root of it. So if our area ratio is 16 over 9, our length ratio is then 4 over 3. Now I can deal with that length. And I'm going to quickly draw a picture to make sure I can even solve for it, because if I don't have corresponding parts, I can't even solve for it. So my B, I'm going to draw 2 triangles. They're going to be 2 similar triangles. One of them is called ham. Now be careful when you label your second triangle. it tells you how it has to be labeled. H corresponds to R, A and I, M and B. So H corresponds to R, so since H is in the bottom left, R must be in the bottom left. Since A is on top, I must be on top. And finally, we have B. Then it says that AM is 16, so we'll mark AM as 16. We are looking for IB. Those are corresponding parts. If they are corresponding parts, we can use our length ratio or our scale factor to solve for a missing length. Real quick, ham is top, rib is bottom. Remember that with your fractions. So your ham is your top of all your fractions. So we're going to have 16 over x equals our scale factor of 4 over 3. We're going to use our means extremes, which also is called cross multiplication, to go, okay, 4 times x is 4x. Is going to equal 3 times our 16, so that's going to be 30 plus 18, which is going to be 48. We're going to end up with x equaling 12. We did start with centimeters, so we should probably write 12 centimeters because that is our length of IB. So if I'm looking for a length, I have to know the length ratio. If I'm looking for an area, I have to know the area ratio. The thing that links them is either I have to square it. If I have a length ratio, I square it to get my area. If I'm given my area ratio, I have to take the square root to get my length. So that's the link between two of them, squaring or taking the square root. All right. Our next example says we have cat and as close as I could get to mouse with 3 letters. You can picture an OU in there, right? So we have cat is similar to MSE. Let's go ahead and draw 2 triangles and call them cat and MSE. So there's one triangle. There's another triangle. They do say that they're similar, so let's put a similar statement between them. Let's label the left one cat. Notice I put my A on the bottom right. A has to match up with S. So if A is in the bottom right, S must be on the bottom right. You may have labeled it slightly different. C goes with M, so if C is in the bottom left, M is on the bottom left. And we're left with E and T matching up, so both of those are on the top. All right, it says that ME equals 6. Cool. It says that CT equals 12. Awesome. Then it says if the area of cat is 72 centimeters squared, so our area of this guy equals 72. Then find the area of MSE. So the area of MSE, let's just call it X. I don't know what it is. In order to compare areas, I have to have an area ratio. Well, they only gave me one area, so I can't come up with an area ratio, but I can use our length ratio to come up with our area ratio. So let's go length ratio first, which is also called scale factor. Our length ratio, let's do cat over mouse. Cat over mouse, our length ratio would be 12 over 6, which I'm going to simplify down to 2 over 1. I'm going to leave it as a fraction because the ratio works with 2 things. I need to have 2 over 1. Don't put it as 2. Remember, we did cat over mouse. So maybe I'll mark that this is cat, and this is our MSE. All right, my length ratio is 2 over 1. What is my area ratio then? If my length ratio is 2 over 1, what is my area ratio? Yes?
4 over 1.
It would become 4 over 1 because we square the top and bottom. So it would be 2 squared over 1 squared. 2 squared is 4, 1 squared is 1. That is my area ratio, where I have cat over mouse. Well, I know the area of my cat is 72. So now when I solve for this, we're going to have 72 over my missing area is going to equal my ratio of 4 over 1. Means extremes would give me 4x equals 72. 72 divided by 4 is not 19, it's 18. They did give us centimeters, so we'll go centimeters. Oh, it's squared, actually. Centimeters squared. Because we are talking about area. Questions on any one of those steps? Okay, let's continue on. Our next one says that we have rect and angle. They're both four-sided figures. They're similar to each other. It says that the area of their ratio, or the ratio of their areas is 9 over 6. What is the scale factor? If our area is 9 over 16, what is our scale factor, Sam?
3 over 4.
3 over 4. Perfect. It'd be 3 over 4. That 3 comes from, it's the square root of 9. This 4 comes from the fact it's square root of 16. What is the ratio of their perimeters? If you don't know what that is, you need to turn to your other side. Yes. It is also 3 over 4. That is what I said. You have to know this. Your scale factor is the exact same thing as your perimeter ratios. Yeah.
Oh, no.
Oh, sorry. I just saw movement out of the side of my eye. All right, so that's 3 over 4. The next thing it says, if LA equals 24, then what is the length of TR? Since we're dealing with lengths, we know we're going to use that length ratio or that scale factor. Let's draw our pictures really quick, because I'm always big on drawing pictures and making sure you get stuff correct. So we have two four-sided figures. I'm going to go ahead and make them rectangles because it's just the easiest thing to draw. They are similar. One is called rect, and the other one's called angle. I'm going to go RECT. Make sure you either go counterclockwise or clockwise. Naming your first one isn't that important as long as you go counterclockwise or clockwise. Naming your second one is very important. Your R and A have to match up. So we should have A on the bottom left. Your E and your N must match up, so we need to have N on our bottom right. Then we're going to have G in the top right, and then an L right there. That way all of our stuff matches up. All right, it says that LA is 24. It says that I'm supposed to find TR. Are those corresponding parts? Yes, make sure you check that first. Make sure it's corresponding. If it's not corresponding, you can't solve it. So they are corresponding. Here's the problem. I need to know which one of these is the top of my fraction and which one is the bottom of my fraction. Does it specifically say which is your top and which is your bottom with your ratio? Yeah.
Don't you know that, like, because it says rect first?
Because it says rect. If it says nothing else, if it doesn't specifically say, hey, rect is on bottom or on top, you are going to go, all right, rect came first in the statement. It says rect is being compared to angle, and their ratio is 9 over 16. Because of how it's written, you're going to then assume that they meant rect is on top, and angle would be our second one. They're basically saying rect to angle is 9 to 16. It stays in that flow of a sentence. All right, that means our rect is on top. Rect is our top. Angle is our bottom. We're talking about length, so we should have a length ratio. Length ratio is 3 over 4. So we're going to say top over bottom, which would be x over 24. Is going to have to equal our length ratio, which is our scale factor, which is 3 over 4. Using our means extremes, we're going to have 4x equals 72. In other words, x is going to equal, they didn't give me any sizes, so we're going to say x equals just 18. So make sure when you're solving for these, if I say you're looking for an area, you better have an area ratio. If I'm saying length, you better have a length ratio. The biggest mistakes people make on this test is they see this 9 over 16 and they're like, I'm going to use that for everything. This is your area ratio. It doesn't work for lengths. All right, our very last one has two trapezoids. We have trap is similar to zoid. And then it says the ratio of their areas are 16 over 25. Real quick, everyone pay attention to what I'm about to say right now. Is the area of zoid equal to 16? Is that the actual area of the trapezoid? No, it is not. It's part of a ratio. These are not the actual, most likely they aren't the actual areas. These are just the ratios between them. All right, this one could be 32 and this would make this one 50. We don't know what the actual are. We just know the ratio. Just remember, we don't know the actual values right there. All right, but we have zoid over trap. That means zoid is going to be our top of anything we use. And trap is going to be our bottom. I'm looking for lengths. Can I use the area formula to compare lengths? No. What do I need to find first before I can combine those two lengths? The hint is lengths. Scale factor or length ratio, either one, however you want. We need a scale factor. What is the scale factor of this one? Yeah. 4 over what? Not 4 over A. What's the scale factor? If our area is, what was that? 4 over 5. Yep. I knew you had it. You're trying to get ahead of me, weren't you? So our scale factor is 4 over 5 because the square root of 16 is 4. Square root of 25 is 5. Now we can compare the lengths. Now we can go, okay, this is my top, so we'll have our 4 over A is going to equal my scale factor of 4 over 5. Using our means extremes, we'll come up with 4A equals 20. We'll have A equals 5. And we'll do the same thing with our B. Well, this is our top. This is our bottom, so we'll have 8 over B equals the same scale factor of 4 over 5. That's going to be 4B equals 40. We'll have B equaling 10. And we finish the problem. The big thing is what you're dealing with, you have to have a factor for. If you're talking about area, you have to have an area factor. If you're talking about length, you have to have a scale or length ratio. You have to know what you're talking about. That is the biggest mistake people are going to make on the test. They're going to take that 16 over 25 and use it for lengths. Don't be that person. Be the one that remembers I need to have a length ratio or I need an area ratio depending on what we're talking about. All right, any questions on what I covered today? All right, then let's go over homework questions from that B and C. Whoa, yeah.
So if it doesn't say which is the top and bottom, how do you know?
It will always give you a hint. So are you talking about like this one where it didn't say specifically? You're going to go with how they listed it. So they said rectangle to angle equals rectangle to angle. If it says nothing else, you're going to take the order they said it in the beginning, and that'll be the order of the fraction. Otherwise, they'll give you some kind of indication like on this one. And if you're on the test and you're not sure, you can ask. You can ask because it shows me you're thinking about it and you just didn't know. Okay? Are these questions on this stuff or on the... Okay, yeah, man.
On the other one.
Okay. Yes?
This one, how do we know which one is the top and bottom on number 2? Like, what's the hint?
On number 2?
Yeah.
I picked it.
Oh, you can pick it? I thought...
Yeah, this one they didn't give us any ratios.
Oh, okay.
So I just said, I'm going to make the length ratio 12 over 6 with cat over mouse. So that one I picked it because they didn't give me one to begin with.
Oh, okay.
Sorry.
For the,
What was that?
for the homework.
Okay, for the homework. Does anyone have any questions on this stuff? Okay, what homework?
Number 25.
All right, number 25 says we have two circles that have both radii of 6 centimeters, and they're 6 centimeters apart from each other. Because they do say they're 6 centimeters away and their radii are 6 centimeters, that's going to be our hint on how to draw it. So we're going to have one circle here. We're going to have another circle here. Because of the fact that their centers are exactly 6 centimeters away, that means that they're going to overlap through their centers. It's the only way. It's the only way for this to be the radius and the distance between the two. So that's the beginning of our drawing. The next thing we're going to do is we are going to actually create triangles and sectors. So what I'm going to do is I'm going to draw a line here. It won't let me go all the way to the point, but about there. Note that that must be 6 as well because it's a radius. And then I'm going to draw one from here, which is also 6. Now, why it's important to draw this triangle first is notice that this is a 6, 6, 6. That's an equilateral triangle. So what's the measure of this angle? 60. Yep, it's going to be 60 degrees. That's important. It's important that this is 60 degrees because when I draw this on the other side, this is also going to be 60 degrees. So this angle right here is 120 degrees. Now what I want you to kind of focus on, we need to find all of this, right? That's our goal. I'm going to cut it in half. I'm going to cut it in half. Let's cut it in half with green. I'm going to cut it in half. And what I'm going to do is I'm actually going to find, let's go back to green. I'm actually going to find this area here. And I'm going to color it all in because it's not all that important, just this part is. I'm going to find that. Because once I find that, once I double it, then I have all the area. Well, look at this drawing right now, Tori. This is 6. This is 6. This is 120 degrees. Do you see this sector right here? All right, so our goal right now is we are going to, let's see if I can do it in yellow. I'm going to find the area of this entire sector. And then what I'm going to do is I'm going to subtract out the triangle, and I'll be left with that green section. Really quick, it's easier said than done. But if you look at my answer key, at least it'll make a little more sense now, maybe. So what I did is I drew this little shaded, and I turned it, and I said, well, this is that 6. This is this 6 here. So this is the sector I want to find, and this is the segment I actually want the area of. So the sector area is pretty easy, because we already said this is 120, right? So it's just 120 divided by 360 times pi r squared. Our radius is 6. That's where that came from. In order to find the area of this, you do have to divide it into a 60, 30, 90 triangle so that you can find the height and the base. But real quick, can everyone pay attention to me right now? On the test, you might get to one that is just complicated. It is like this, where you're just like, okay, I know it's the sector minus the triangle. I can't quite find the triangle. Tell me that. Tell me what your big picture plan is. Tell me I'm going to do the sector minus the triangle. I got the sector. I can't quite get the triangle because I wasn't quite sure. That's way more points than just having a blank answer. But Tori, is that, you think, good enough?
Yeah.
Yeah. Other questions? Yeah. 21B. It says find the area of the shaded region to the nearest square centimeter. And we're using a square root of 7 equals. So we're just rounding stuff. All right, so our big thing is we need to do sector minus triangle, right? So the information they gave me was bunch of little triangles. They gave me that I have chord AB somewhere. We have a center O. And did it give me that the radius is 12, I think? And that the length of AB is going to be 18. Okay, I need to find the area of the shaded... I need to find the... What am I looking for? Oh, nearest to the square. So the shaded region was just this top section right here, right? All right, so that means I need to come up with the whole sector minus the triangle. Okay. Well, we already found that angle in the previous problem, right? We came up with it being 98 degrees. So let's look at this real quick. So it's going to be area of sector minus triangle. Well, sector is 98, right? Do we agree it's both 98? Okay, 98 divided by 360 times pi times 12 squared. So that's our sector. Now we need to subtract out our triangle. Well, I pulled out half the triangle. I pulled out half our triangle where we have 9 and 12. And we knew that this one was 48 well, we didn't even need the 48 degrees. We can just go a squared plus b squared equals c squared. So I found that this length right here is 3 square root of 7. So this triangle's area is going to be half a base. Our base is 18 times our height, which is 3 square root of 7. That's where I came up with that. And that's the end of really the problem. It's just plugging in and rounding. You might come up with a slightly different answer than me depending where you rounded. All right, other questions? Does that all make sense? I'm sorry, I kind of rushed through it. Okay. Other questions on the homework? Hands up.
Yeah, for 25, I'm still confused on what you do once you get like that half segment.
The half of it?
Yeah, half of the segment.
You
Or,
just
like how you solve for half the segment by doing 36 and 90.
on number 25?
Yeah.
Do I already have that one up here? Which part?
Just like what you did, like in the second part where you had.
Here?
Yeah, what you did there.
Well, we need to know the area of the sector. That's the easy one, because it's just 120 over 3. Did you get that part?
Yeah.
Okay, so the sector is easy. The triangle, I need to find the area of the triangle. So I had to use a 30, 60, 90 triangle because I only knew the hypotenuse.
Oh, and then you multiply that. Yeah.
So I used 30, 60, 90 to get my height is 3, because it'd be s, 2s, s squared of 3. So this would be 3, this would be 3 squared of 3. Then I knew that the base was 6 squared of 3, and the height was 3. So that's where I did the 1/2 6 squared of 3 times 3. Other questions? Yeah.
The total would be, I know you already did it, but did you just like do that like yeah, did you just use like pi and everything?
Yeah, so it says rounded to the nearest square centimeter, so you actually have to type in, like you just hit pi into your calculator, and you're going to come up with a decimal. That's why I don't have pi in my answer. Most of the time, you're just going to have pi in the answer. Other questions? Okay, the rest of the time is yours. Make sure you have your homework out so I can quickly walk around and check it all. But the rest of the time is yours to work. This isn't a terribly long assignment, so even the short